This video is part of 8D lesson of logic unit. The definition on this first slide is called equivalence. So go ahead and highlight that. The definition is if two propositions are linked with if and only if, then it's considered an equivalence. So how you would say it is P if and only if Q. In symbolic form, this is what it looks like. When you have an equivalence that's true, you would say P then Q and Q then P. All right, so here's an example of an equivalence. Proposition P is that I will pass the exam. Proposition Q, the exam is easy. So to write it as an equivalence, that's going to be at the bottom. I will pass the exam if and only if the exam is easy. The two above, I'm going to put in the teal here, this is and implies if I pass the exam, then the exam is easy. Or you can switch the order. If the exam is easy, then I'll pass it. So to help with truth tables that we've been working on this unit, here are the rules to help with your truth table. So if you have a P then Q, so if P then Q, it'll always be true except for true false. And we have it on our previous video. Switch the order of the propositions. If P then Q, it'll always be true except for true false. Now for implications, sorry, equivalence. This is what we're talking about, the equivalence. The rule is for an equivalence to be true, all must be true for it to be true. So here's what I'm going to show you here. So here's an example. You have your two propositions that are true here in your implies. Both have to be true in order for your equivalence to be true. So again, true, true, true. False, false, true. So they both have to be the same. On our next slide is a helpful hint, and these are created in your formula packet. So we've already talked about these up to here in our previous videos. So those are in your notes already. And now we're adding in these two columns. So here is your first one, which is an if-then statement. Then, which is called, the rules are true, false, true, true. How to help you keep track of it is right here. For the statement to be true, if P is true, then Q must also be true. If P is false, then Q can't be either. So looking back on the original propositions, here's true and true. Both of them are true, so we'll end up with true. True, then false. So this has to be then false. False, then true. Then it can be true. False and false, so it is true. All right, I'm gonna go ahead and clear that screen. Our last one is our equivalence. So that symbol is denoted here. It's your if and only if. And again, we give this table to you in your formula packet. So going back to the original two columns, true and true, you'll end up with a true equivalence. True, then false, you'll end up with a false statement. False, then true, you'll end up with a false equivalence. Last one, false and false, you'll end up with a true equivalence. So hopefully that'll help you with the truth tables on our next video slide.